Hello everyone. In this question, it is given that if the solution set for ax square plus bx plus c greater than 0 is the open interval 2 to 3, then we have to find the solution set for cx square plus bx plus a less than 0. So we are given an expression ax square plus bx plus c which is positive, which is positive in the solution set open interval 2 to 3. Okay. Now, if this is the case, then the graph should be something like, if this is your x-axis, okay, if this is say the x-axis, so for this expression to be positive in this open interval 2 to 3, the graph should be something like this, where this is where this quadratic expression is positive, right, within the interval 2 to 3. Okay, so if I write this and this as 2 and 3, then we see that the curve is 0 at 2 and 3, right? So this implies that if we take the equation ax square plus bx plus c equal to 0, this must have roots 2 and 3, right? So if these are the roots, only then will the expression be positive inside this interval. Okay, in the open interval 2 to 3, the expression is positive. It is above the x-axis, right? So if this is the case, then we have this ax square plus bx plus c is the same as a times the root x minus 2 times x minus 3, right? We can factorize this in the similar manner. So this implies that if we try and simplify, we get ax square plus bx plus c becomes a times x square minus 5x plus 6. So this one simplifying further becomes ax square minus 5ax plus 6a. So on comparing both, we get b is equal to minus 5a and c is equal to 6a, right? Also, the graph is a parabola which is open downwards. Okay, so for this reason, we must have our a from this curve itself. We can see clearly that a has to be negative. Otherwise, the curve will not be in this shape and this value is not positive in this solution region. Okay, so we must have a to be negative. So if a is negative, from here we can conclude that since a is negative and this is a negative, b will get become positive and this c will become negative. Okay, these are the two conditions we can deduce here. So now we have to find the solution set for cx square plus bx plus a. So now cx square plus bx plus a is less than 0. So here, if I try to take a common here and rewrite this as first term as c upon ax square plus b upon ax plus 1 less than 0, then this becomes a times c is 6a, right? So c upon a will become 6. So this becomes 6x square. Similarly, b upon a will become minus 5, right? So this becomes a times minus 5x plus 1 is less than 0. Okay, so on dividing both sides by a, since a is negative quantity, right? So on dividing both sides of this inequality by a, the sign of the inequality will change. So this becomes 6x square minus 5x plus 1 greater than 0. Since a less than 0, the sign changes. Okay, so if we try to factorize this quadratic expression, this is product is 6 and sum is minus 5, so this can be minus 3 minus 2. So this becomes 6x square minus 2x, so this becomes 3x minus 1 times 2x minus 1 is positive. Okay, So if I take 3 out of here and if I take 2 out of here, this becomes x minus 1 upon 3 times x minus half is positive. So if product of two numbers is positive, this implies that x must be smaller than this smaller number, or x must be larger than this larger number, right? 1 by 3 is smaller than half. So this implies x must belong in this interval minus infinity to 1/3 union of half to infinity for this inequality to hold. Okay, so this is the required final solution set of x. Okay, so this is the final answer. Okay, if you have any doubt in any step, okay, you can highlight it in the comments. Okay, I'll reply to you. Otherwise, this is finished. Thank you.